Okay, I am Dr. Babu, Professor and the Head of the Department of Biomedical Engineering, Sri Sanmuga College of Engineering and Technology, Sagagiri, Salem District. Okay, in this class, I am going to take the subject about the microprocessor based surgical diathermy. So, diathermy already we have seen, dia means through, thermy means temperature, through the temperature. So, some of the diseases like pain, swelling, like that. Already in older days, we are applying the heat by giving the hot water treatment like that. So that is also the olden days diathermy. Nowadays, we are using electrical energy. We are applying the electrical energy. Okay, that is diathermy. Okay, diathermy principles in previous classes. Diathermy principles, instrument what we are using, electrodes, different techniques, these are all already we have seen. Now in this class, the advantage is equal to, we are going to explain about the microprocessor based surgical diathermy. Okay. Introduction to microprocessor based surgical diathermy. Okay. In the diathermy, the control, it was controlled by microprocessor. That's why it is called microprocessor based diathermy. When the maximum output voltage becomes about 600 degrees centigrade, severe carbonization occurs in the diathermy. Generally, we are diathermy is used for the cutting, coagulation, fulguration, like that. Okay, the variations in the output voltage considerably affects the quality of the cutting. When the maximum output voltage becomes above the 600 degree, South carbonization occurs. Okay, it is, so that's why we have to go. We should not go above the 600 degrees centigrade because the tissue will be carbonized. When the minimum value of the output voltage goes below 200 degrees centigrade, cutting action is not achieved. This is a problem in the surgical diathermy when we are using the DC current. Okay, so if it is below 200, cutting operation is not able to, not sufficiently achieved, and the above 600, the tissue will be carbonized. So in between the 200 to 600 only we have to use the temperature. To overcome this problem, we are using the microprocess controlled automated system have been developed so that the output voltage or the spark intensity remain constant. So if we are using the microprocessor, we are getting the out, steady output voltage, or the spark intensity will remain constant, same intensity, okay, will be developed when we are using the microprocessor based surgical diathermy. Okay, here the variables, the current, tissue resistance, voltage, and spark intensity are registered by means of an inbuilt sensor system and then processed as defined output signals. Okay, the automatic control operates on two different criteria. One is voltage controlled, another one is spark controlled. Okay, voltage control means by adjusting the voltage. Spark control is equal to the spark intensity, control of the intensity of the spark. Okay, first one is voltage control. Wherever by the selected voltage is controlled and held constant, that is voltage control. And the spark control by which the selected spark intensity is held constant. Okay, first one is we are maintaining the constant voltage, and the second one is we are maintaining the constant intensity. So these are the two different criteria in the automatic control microprocessor based surgical diathermy. Okay. The design of the control system ensures that the cutting quality is independent of size. The cutting quality of the cutting is independent of the size and shape of the electrode, the type and speed of the cutting, and the varying tissue properties. So this is the microprocessor based surgical diathermy. Okay, in continuation with the microprocessor surgical diathermy again, the microprocess controlled machine is also provides the following coagulation modes. One is soft coagulation, second one is forced coagulation, the third one is spray coagulation. What is coagulation? Already we have taught, already we have explained. Okay, now we can go for the soft coagulation. So what is soft coagulation is, there is no electric arc produced between the coagulation electrode and the tissue during the entire coagulation process to prevent the tissue from becoming carbonized. Already we have explained. Okay, because of the high temperature, the tissue will be carbonized. That is the disadvantage. To minimize the carbonization or to avoid the carbonization, what we have to go for is the temperature has to be reduced. So one technique what we are using is without any electric arc. There is no electric arc produced between the electrode and the tissue. Okay, generally electrode and tissue, the arc will be produced. That's also one of the technique. So the first technique, there is no electric arc is produced between the coagulation electrode and the tissue during the entire process of coagulation. So it is used to prevent the tissue from becoming the carbonization. This is called soft coagulation. Coagulation electrodes in direct contact with the tissue to be coagulated. You can see in the diagram, the first diagram, the electrode, coagulation electrode, what we are using is ball electrode. It touching the surface of the tissue. Okay, touching the surface of the tissue, there is no arc is produced. There is no gap between the electrode and the tissue, and there is no arc is produced. This is called soft coagulation. Next one is, you can go for the diagram B. This is called forced coagulation. Soft coagulation. Next one is forced coagulation. Okay, in forced coagulation, electric arcs are generated between the coagulation electrode. Okay, there is a small gap between the electrode and the tissue, and the electric arc will be generated between the coagulation electrode and the tissue. In order to obtain deeper coagulation than could be achieved with the soft coagulation when using thinner or smaller electrode. So in this case we are using the thinner electrode or smaller electrode for forced coagulation. So the tissue will be coagulated in the deeper area in the forced coagulation. The diagram B shows the forced coagulation. Then we can go for the third one, spray coagulation. The figure C in this diagram shows the spray coagulation. Okay. Okay, electric arcs are deliberately produced between the spray electrode and the tissue. Okay, there is a gap between the sufficient gap between the electrode and the tissue, so that electric arcs are deliberately produced so that direct contact between the electrode and the tissue is unnecessary. There is no need. Spray coagulation, so there is a spark or spray, okay, will be developed in between the gap. So this spray coagulation is used both for surface coagulation and the hemostasis of vessels not directly accessible to coagulation electrode, such as those hidden in bone fissures. So that is the advantage of the spray coagulation. So the diagram, all the three diagram explains about the soft coagulation. B is equal to forced coagulation, C is equal to forced spray coagulation. Okay, wherever the coagulation is not possible, okay, in that cases, okay, just like that homeostasis or blood vessels are not directly accessible to the coagulation electrode. In that cases, we can use the spray coagulation. Okay, then safety features. What are the safety features in the microprocessor based surgical diathermy? So these are the points of the safety features. First one is, an error detection system is available. Okay, if there is an error, the system will intimate there is an error. So the error detection circuit will find out the error and display. Okay, so an error detection system is available. It will give the signal whenever there is an error. An error signaling system also available. An error storage system. Okay, the history of error can be stored. Error storage system is available in the system. low frequency leakage current monitor. If there is any leakage current, low frequency leakage current, that will be monitored. That is, that facility is available in the system, microprocessor based system. High frequency leakage current also can be monitored using this microprocessor based system. Output error monitoring, time limit monitoring, operating errors, and neutral electrode safety system. These are all available. The system is equal to programmable and user friendly. Okay, it is we can change the program. That depends upon the parameters required. Okay, the heat, high heat or low heat, time, like that, and it is very user friendly. Frequently used standard settings can be generated or can be programmed by the manufacturer before delivery, and individual customized settings that can be easily and swiftly be programmed later. This is an advantage. Next one is a power peak system that delivers a very short power peak at the beginning of the electrosurgical cutting to start the cutting arc. Therefore, average power can be limited to relatively small amounts, which signifies an improvement in protection against unintentional thermal tissue damage. So, this is the advantage. Next point is continuous monitoring of current and voltage levels and making automatic adjustment under the control of microprocessor provides for a smooth cutting action through the procedure. Okay, so we can continuously monitoring the current level, voltage level. Okay, and the adjustment can be automatically done by using the microprocessor. This is the advantage and the safety features included in the system. Okay, next, electrosurgery techniques. What are the different electrosurgery techniques or electrosurgery techniques? The electric current can flow only if the electric current is closed. Electric current can flow only if the electric current is closed. In terms of current flow, there are two types of electrosurgery techniques. One is monopolar and bipolar. Already many classes I have explained about the what is monopolar and bipolar. In monopolar technique, okay, the current flows from the active electrode through the patient to the neutral electrode, that is called patient plate, that is reference, from which it returns to the generator. Only one active electrode. That is called monopolar. In bipolar, we are having the two active electrode. So current is passing from the one active electrode to another active electrode through the tissue. It is called bipolar. Okay. In monopolar, we are having the only one electrode for cutting or coagulation, whatever may be. Below the tissue, we are using the patient plate. It is also called indifferent plate. Already we have seen. So from the electrode, cutting electrode, current is flow through the tissue or body, human being, and it is collected by the human plate. So only one electrode is used. It is called monopolar technique. The cutting or coagulating effect depends on the contact area between the monopolar active electrode and the tissue, which is very small compared with the contact area between the patient plate and the patient skin. Okay, in bipolar technique, two electrodes are used. The current flows through the tissue between the tips of the two electrodes. Okay, and the returns to generator without passing through the patient. Okay, the entire current is not passed through the patient. Only through the affected tissue the current is passing, and again it returns to the active electrode to the generator. It is called bipolar technique. The bipolar surgery is not only safer than monopolar, but it is also more precise since the current only flows locally at the specific site where it is actually required for each generation. In addition, the risk of inadvertent burning of the patient at the patient plate is very low. Therefore, bipolar technique is becoming a method of choice whenever possible. Okay, whenever possible, the doctors will choose the bipolar technique. If the bipolar technique is not possible in some of the places, then the doctors can select the monopolar technique. Okay, that is the difference between the bipolar and the monopolar technique. Okay, these are the some of the electrodes, different types of electrode which is used in the surgical diathermy. Okay, so the bipolar technique is used in most of the application involving surgical diathermy. The high potential terminal of the diathermy is connected to the cutting electrode, which is mounted in an insulated handle. Insulated handle. The cutting electrodes are available in a variety of shapes. Now we can go for the different types of shapes. Shapes of the electrode. One is needle electrode. You see the diagram. A is equal to needle electrode. A point, a sharp point. Then angulated electrode. There is an angle, so that's why it's called angulated electrode. So end of the electrode is there is a loop wire. So it's called wire loop electrode. Next one is angulated band loop electrode. Angulated band loop electrode. Next one is standard lancet, straight lancet electrode. These are the some of the different shapes of the electrode. Lancet electrodes are normally used for cutting. Needle electrodes are used for the epilation or desiccation. Loop electrodes are employed for opening up channels and the extirpating growth, etc. The active electrodes are coagulation purposes or ball type or plate type. In electrosurgery, the surgeon is able to switch the higher frequency current on and off himself. So whenever need, he can switch on or switch off. That depends upon the surgeon. Okay, that depends upon the electrosurgery needed. Okay, this can be done with a fingertip switch in the electrode handle or a foot switch. These are the electrodes used. Okay, in addition to that electrode, the low potential terminal of the radio frequency output is connected to the indifferent or dispersible electrode, which is a lead plate wrapped in a cloth bag soaked in saline solution and stabbed onto the patient's thigh. An alternative arrangement An alternative arrangement is to use a flexible, non-crumpling stainless steel sheet plate without any covering. Good contact is established with the film of perspiration rising between the plate and the patient's body. The alternative approach is used to capacitively coupled plates in which no direct contact is made between the metal of the indifferent electrode and the patient's skin. This is also one of the technique. Okay, there is a problem arise if the paste is not cleaned from the plate after use, as it may form a hard insulating layer. So we have to clean the plate surface. The electrode comprises a large sheet of thin metal sandwiched between the two sheets of neoprene, which formed a capacitor with the patient's body. This capacitor allows an easy path for the passage of the high frequency diathermic currents. But there is a problem of introducing the burn hazard when alternative current path when other equipment with the grounded person current is used. Okay, the common reason for faulty performance of the electricity unit is improper placement of the indifferent electrode. That's also possible. This electrode must be placed in firm contact with the fleshy portion of the patient and as nearly as possible to the operating site. Poor contact or excessive distance from the operating site causes a loss of energy available for the actual surgical procedure. That's all about the surgical diathermy. That is microprocessor based surgical diathermy, techniques of surgical diathermy. Thank you.